Alright, greetings everybody. We are going to do our best to talk through the main points of the 3D project and hopefully answer any questions that you might have that we forget to talk about in class or that you want to go back over and see. So I'm just going to kind of walk you through this. Now the 3D project is introduced down here below day 17 in our modules, and you can read all of this by yourself, but basically you're going to do a craft project with a partner, and then you're going to create a 3D printed miniature version, a little mini of it based on a scale factor that is done on the 3D printers in the library. Now this is a past semester's projects. For example, you can see that each project has its craft model and its miniature version. The boat was made out of foam board, not foam board, but like the craft foam stuff. The pineapple was made out of wood. The glitter one is the one that they created. The blue one is the one that they printed, and you can see that they missed the whole scale model bit, that this should have been scaled down to 1/2 or 1/3 of the original. Everybody else got things scaled down. The cat was made out of cardboard. The apple, I can't remember. I think they did layers of like foam poster board. And then of course we've got the train. The mushroom went sideways when they did the 3D print. Their 3D print did not turn out well. We have another boat here, and of course the ice cream sundae. Things that the projects have in common: they're all about the same size. They're not huge. All of your measurements need to be given in centimeters, but if you were to measure them in inches, these are all less than a foot tall, maybe like 6 to 8 inches tall. We're going to look at some measurements of them. And then of course the miniatures are scaled down by 1/2 or 1/3 or 1/4 of the original. Okay, so back to our project plan. More than 2 basic geometric shapes. You need to have an arc and an angle that is not 90 degrees. So you can see that each of these has several smaller shapes put together. The boat has a 1/2 cylinder, it's got triangles, and it's got a rectangle. The duck, they did a great job with the duck. They did like a trapezoid, they did a 1/2 cylinder, they did triangles. But each of these can be broken down into smaller, simpler shapes. They are prisms. They're all prisms with 2 identical bases. The base, for example, is the pineapple shape, and then the lateral face is that rectangle that would wrap all the way around. For the boat, the base is the boat shape, and the lateral face is that rectangle height or width that's going to wrap all the way around. So each of them is a prism. You don't have any spheres, no hemispheres, no cones as part of the shape, so that it has 2 flat bases. You're going to develop a plan with a partner. If you don't already have partners by the time we talk about this together, we'll do random selection of partners. You'll submit a rough sketch just on paper so that we can talk about making sure that you have picked something you can be successful at that is hard enough for me to count it and not too hard. You're going to then create that base view that matches your detailed sketch. You're going to use 3D modeling software to create a 3D print mini version using a scale factor. That scale factor is important. You're going to do calculations on surface area and volume. And I tell you what those calculations should include. You're going to turn everything in. Now, I have different small deadlines set, and you'll see those showing up on your calendar so that you get to the entire grade is a accumulation of those earned points along the way. I forgot to open this up. Let's see if we can get this to open up. So here's your rubric. And as always, I encourage you to print this rubric in advance so that you can look at it as you go. This rough sketch, that's that first submission deadline, that's due the 29th, March 29th. You can earn up to 10 points on it. And once you have earned or not earned those 10 points, that's done. So you've got to make sure you're working on this as we go, because you can't come back and earn those 10 points at the end. Your crafted model, the model you build out of foam board or styrofoam or wood or cardboard or whatever you plan to do, it is due on April 12th, also worth 10 points. Then you're going to, from that crafted model, do a graph paper base plan that has exact measurements on it. And it's due that week after for April 19th. The 3D printed mini version isn't due until the end of April, April 26th, also worth 10 points out of the 100 points for this project. I have already made contact with someone in the library who will help you out with this and give you a little bit of guidance if you need help with the SketchUp program to get the software program going so that you can print your miniature scaled down version. The computations, reflection, and will not be due until you do the presentation, which is on our last day of class, May 3rd. And you'll turn in everything at that time. You're going to go back and resubmit all the things that you've already turned in. Now again, all of these deadlines are given to you on your calendar in Canvas, and we will look at them again. But I just wanted to go through and make sure you understand that this is a 100-point project, but the last 50 points are all that get turned in at the end. The first 50, 10, 20, 30, 40, not 50, I'm sorry, are due previous to that final turn-in date. So that gives you some mini goals along the way so that this isn't all done at the last minute overnight. Okay, so we looked at examples of projects. Here's an example of the calculation submission, and you can see now they did a few more measurements than I need, but you can see that they have the measurements of the segments marked in centimeters, and I just need to the nearest 10th of a centimeter. They did to the nearest 100th of a centimeter because they allowed their software to do the measurement here. They measured angles for me as well, and they have the areas marked out so that I can see how they did the calculations of the areas. They had the lateral surface area, total surface area, volume. Here's a different project. This one was a fox. Again, you can see that they have everything measured out. They have side notes for me so that I can see when things didn't go quite right. Does not have to be done. Your measurements do not have to be done on the software. They can be written out. That is not a problem. This was very clear. It was organized. I could find the parts that they were referring to, and I could check their calculations super easy. And that's what I'm going for. I'm looking for being able to follow along and check the calculations. Here's another one that was done by hand. I liked it. It was great. I could see what they did. I could see where their calculations came into play. They even color-coded for me so that I could check their surface area and volume calculations without a lot of work. Basically, I need to be able to follow along without spending an hour trying to find your calculations. I need to be able to follow along where you got your measurements, how you found your surface area and volume calculations. When you get ready to do surface area and volume of the miniature version, you will just apply a scale factor, which we will talk about in this next unit. Alright, so that is that's your project. Hopefully that answers some of your questions. Make sure you read these instructions very closely. Make sure that you have downloaded your rubric so that you know when things are due. I have this posted both in Module 2 here after day 17, which is where we are, and I have it posted in Unit 3 so that you have the same set of information available in both places so that you can go back to find it. Alright, there you go.